Given question, draw shear force diagram and bending moment diagram of cantilever with point load as well as uniformly distributed load.
In this video, we are going to learn how to draw shear force diagram as well as bending moment diagram for the cantilever. If we observe, there are 2 point loads or concentrated loads and one uniformly distributed load acting in downward direction. And this cantilever is fixed at point A. So the reaction will act at point A in the opposite direction. That means it is in the upward direction. So we will show the reaction force at point A in upward direction. And we have to find out the magnitude of this reaction. So we will take here the summation of all vertical forces is equal to 0. So sign convention, we will consider forces which are in downward direction take negative sign, and the forces which act in upward direction we will take the positive sign. Now what about the uniformly distributed load? So it is 2 kilonewton per meter and the total span is given 2 meter. That means total force is equal to, for 2 meter, 2 multiplied by 2, that is 4 kilonewton. And this uniformly distributed load will act at the middle point of the span. So total span for in between C and D is 2 meters. So we will consider here the middle point, and at this middle point we will show here in terms of point load 2 multiplied by 2, that is 4 kilonewton. Now we have to find out the reaction at point A. So we will consider the equilibrium of this given system and summation of all vertical forces is equal to 0. So forces in downward direction we will give negative sign, that is -1, -4, -1. And forces in upward direction, that is reaction at point A, that is plus RA is equal to 0. Therefore RA is equal to, so if I transfer all these values to the right hand side, then it will become positive. So 4 plus 1, that is equal to 6 kilonewton. So we have to mention here this RA is equal to 6 kilonewton. Now we will find out the shear force in between D and E. So how to find out this? So we have to consider one section line in between this span. So I will show here the section line that is known as XX. There are two ways to calculate the shear force. We can take the summation of all the forces either on the right hand side of the section line or left hand side of the section line, and we will follow the sign convention rules. So if we observe here, suppose this is the section line, and on this section line on the right hand side, if forces are in downward direction we have to consider the positive sign, and if the forces are in upward direction then we have to consider the negative sign. In the same way, on the left hand side of the section line, if the forces are in upward direction we will consider the positive sign, and if the forces are in the downward direction then we will consider the negative sign. So if we observe, for this positive sign we will consider the positive shear, and for this negative sign we will consider the negative shear. So how to calculate the shear force between D and E? So here is the section line XX. So we will calculate by using two ways. So first I will take SF. Now we will consider the forces on the right hand side of this section line. So on the right hand side there is the force which is in the downward direction. So for this downward direction, if we observe, on the right hand side we have to consider the positive sign. So we will take here plus 1 kilonewton. Or there is the second method to calculate. So by using the second method we have to take the summation of forces on the left hand side. So if we observe for the downward direction on left hand side, so here is the downward direction on left hand side, we have to use the negative sign. So for these two forces I will take the negative sign. So SF is equal to -1 -4. And on left hand side here is the force which is in upward direction. So for upward direction we will use the positive sign. So I will take here +6. So which is equal to 6 minus 5, that is +1 kilonewton. So answer is same. So we can use any one method either on the right hand side or on the left hand side. So here we can directly write +1 or we can calculate this. Now we will mark the point. So to mark the point, to draw the shear force diagram, we have to first draw the baseline. So I will show here the baseline. Now with reference to these diagrams, we have to extend the lines from point A, from B, C, D and E. Now for this section D to E, we have calculated 1 kilonewton shear force. So this is the plus sign. That means for positive values, we have to consider the upward direction. So I will mark here +1 kilonewton. That is +1 and here also +1. Now how to show this? So here if we observe, only point load or concentrated load is given in between this D to E. So whenever there is the concentrated load, that means the shear force will remain constant throughout the section DE. So I will draw here the horizontal line. Now we will calculate shear force between C and D. So we will consider the section line XX. Now we will apply the same rule. We will take the summation of forces on right hand side of this section line XX. So SF is equal to, now on right hand side forces are in downward direction. So we will consider the positive sign. So which is equal to +4 +1, that is equal to +5 kilonewton. Or we will consider the second way, summation of forces on left hand side of this section line. So here on left hand side force is in the upward direction. So shear force is equal to, for upward direction we will take +6 and for downward direction on left hand side we will take -1. So which is equal to +5 kilonewton. So for this +5 kilonewton we will mention here this value. So because of the positive sign we will take the direction in the upward direction and we will show here the +5. Now if we observe the span for this CD is with uniformly distributed load, and when the load is uniformly distributed load, shear force follow the linear law. That means we have to join these 2 points, that is with from +1 to +5, we have to join with inclined line. Now we will calculate shear force between B and C. So in between BC we will show here one section line. Now we will take summation of forces on right hand side. So I will take for shear force and summation of forces on right hand side. So these forces are in downward direction. So we will use the positive sign, that is +4 +1, that is equal to +5 kilonewton. Now we will use here, or we will take the second way to calculate. So or summation of forces on left hand side. So on left hand side here this force is downward direction. So for this downward direction we will take -1, and this force is in upward direction. So on left hand side for upward direction we will take positive sign +6, and that is also equal to +5 kilonewton. Now we will mark the point. So in between BC, so here is the point B. So I will mark here the point for +5. Now we will join this. So if we observe in between B and C at point B, there is concentrated load or point load. So this load will remain constant throughout the span BC. So I will join with horizontal line. Now we will calculate shear force between A and B, and we will consider the section line XX. If we take the summation of forces on right hand side, so all the forces are in downward direction, so we will take the positive sign, that is +1 +4 +1, that is +6 kilonewton. Or second way, summation of forces on left hand side. So on left hand side for upward direction we will use positive sign, so it is +6 kilonewton. Now if we observe in between A and B, there are concentrated loads or point loads. So here the shear force will remain constant throughout the section AB. So if I mark here +6 kilonewton, then in between this A and B it will remain constant. So I will show here, and we will join these 2 points, and we will join the end point also. Now we will highlight this area. Now we will understand how to calculate bending moment. There are 2 ways to calculate bending moment. We can take either summation of moment of all the forces on right hand side of the selected point, or we can take summation of moment of all the forces on left hand side of the selected point. There is sign convention. So if we observe the point of intersection of this horizontal and vertical line, here is this point of intersection. Now if I take the moment about this point on the right hand side, and suppose it is in anti-clockwise direction, then we have to use the positive sign. And if the moment is in the clockwise direction of the selected point, then we have to take the negative sign. So this is for the cases on the right hand side of the selected point. Now if I take the moment on the left hand side, and suppose it is in clockwise direction, then we have to use positive sign, and if the moment on left hand side is in anti-clockwise direction, then we have to use the negative sign. Now by using this sign convention, we will first calculate bending moment about point E. So I will write here BM about point E is equal to. Now we will take either right hand side or left hand side. So for this question we will take the summation of moment of forces on right hand side. So if we observe at this point E, there is no any force on the right hand side, and at point E 1 kilonewton force act, but the moment, that means force multiplied by the distance from this point. So distance is equal to 0. So if we observe there is no any force on the right hand side, so bending moment at point E is equal to 0, and we have to plot this point on the diagram. So first we will draw here one baseline. And this is the point E, and value is 0, that means here on the baseline we have to mark 0. Now we will move to the next point. So next point is point E. So bending moment at point D. So how to calculate? So we have to take the moment on the right hand side. So if I move the compass about point D, and on right hand side here it is clockwise direction, so we have to use the negative sign. So -1 multiplied by the distance from this point D. So it is 1. So -1 multiplied by 1. That is equal to -1, and unit is kilonewton meter, because we have to multiply with distance. So we have to mark -1 at point D. So here is the point D, and I will mark here the point -1. Now how to join this point E and D? So here this value varies linearly with distance. So we have to show the inclined line. So from 0 to -1 I will draw here inclined line, and this is known as linear law. Now we will move to the next, bending moment at point C. BM at point C. So we will consider the right hand side forces. So if we observe, if I move the compass about point C in the 1 kilonewton direction, then it is in clockwise direction. So we have to use negative sign. So -1 multiplied by distance from this C. So distance is equal to 2 plus 1, that is 3. Then there is another force which is uniformly distributed load, and it is total load 2 multiplied by 2, that is 4. And the distance from this C, that is, this is the middle point. So distance from this C and F is equal to 1. So how to show this? So it is also in clockwise direction. So -4 multiplied by this distance 1. So when we calculate -3 minus 4, that is equal to -7 kilonewton meter. So again we have to mark here -7. So I will mark here point -7. Now how to show this? So it is, this section CD is uniformly distributed load. So for bending moment, whenever there is uniformly distributed load, it will follow parabolic law. That means we have to show the parabolic section in between these 2 points C and D for the span of uniformly distributed load. So I will show here small curvature to join this. Now we will move to the next for this point B, bending moment at point B. So again we have to observe this right hand side forces. So if I move the compass in the direction of 1 kilonewton, then clockwise direction, so negative sign. So -1 multiplied by the distance from this point B. 1 plus 2 plus 1, that is 4. Then -4 multiplied by the distance from this B. So this is the half distance we have to consider, because this is the middle point. 1 plus 1, that is 2. So again we will calculate this. So -4 minus 8, -12 kilonewton meter. So we have to show this mark, -12. Now how to join this? So it is the section for the point load. So in between B and C there is the point load. So it will follow the linear law. So we have to join just by line, inclined line. Now we will move to the next, bending moment at point A. Now again we will observe all the forces. If we move the compass about point A, then it is in the clockwise direction on the right hand side. So we will use the negative sign. So -1 multiplied by distance is 1. Then -4 multiplied by distance in between A and F is 1 plus 1 plus 1, that is 3. Then -1 multiplied by 2, 3, 4, 5. Then we will calculate this. So -1, then -12, and then -5. So -12 and -5, it will become -17, and here -1, that is -18. So -18 kilonewton meter. So we have to mark this point at -18. Now we will join this. So if we observe in between A and B, there is concentrated load or point loads. So we will follow the linear law. So we will join with inclined line. Now we will complete this, and we have to highlight the area. Now we have to mention here for this diagram, this is the shear force diagram. So we will show here SFD. And this diagram is bending moment diagram. So we will mention here BMD. Now if we observe all the values, because of the negative sign, we have plotted in the downward direction from this baseline. So there is not necessary to show this sign. So only we will write 1, 7, 12 and 18 because the direction is downward direction and we have to highlight the area.